I got 1, 2, 3, 4, 5, 6, 7, 8 wrenches in my top drawer. Hey, what's up, guys? This is MJ100K, and today we are going to talk about GM's new V8 engine that is going to be coming out soon. Okay, so this is what this show is going to be. We don't know how the new engine is going to be, what the specs are, or anything like that. We don't have any inside information. But today, my friend Dane and I have decided to do a mental exercise to see how would we design the new V8 if we were in charge of everything. So I know Dane has been thinking about this all week because he loves Chevy engines and he is just ready to go. So, all right, let's look at this article real quick from GM so we can see what we are talking about. All right, so here we go. This is an article from Fox Business if you want to see it yourself. GM investing $854 million to build V8 engines. So here's the article. The automaker has announced $854 million investment in 4 factories to build a new generation of V8 internal combustion engines for its full-size trucks and SUVs. And the money will go toward engine and parts manufacturing at Flint Engine Operations and Bay City GPS in Michigan, in Defiance Operations in Ohio, and Rochester Operations in New York. So it looks like they are getting ready. They're getting the tooling put together for this V8, and we are ready for it. So, Dane, I know you've been working on this. I know you've been thinking, using all the powers of your Silverado brain. So what we're going to do, we're going to hear Dane's idea first. We're going to listen to him, let him make his idea known to the world. And then we're going to hear my idea. And then we're going to kind of just spitball back and forth reactions to those ideas. And then you guys can vote in the comments. Whose idea do you like better? Or do you have your own idea for the next generation of V8 engines? Because Dodge isn't making any more V8s, so they say. Dane, what is your idea for the next generation V8?
I think they're going to just keep piggybacking on what's already awesome. You got, like I said, it's already a V8, which is awesome. They've been doing pushrod engines with 2 valves overhead for, since the 50s. And it's been an awesome proven platform. You know, the LT2 that it's in, like the new C8 Corvette. You know, some guys thought that was going to go overhead cam because there's some benefits there. It stayed in block cam, overhead valve, pushrod. So I say, you know, stick with what works. Stick with the pushrod motor, 2 valves per cylinder. I think the displacement right now they have them at 6.2 is probably the most popular one, at least the one that everybody kind of wants. I think they're probably going to stay in that same displacement range. You know, there's the old saying, there's no replacement for displacement, so that ain't going anywhere. If it was me too, something that they don't have in all the naturally aspirated engines is piston oil coolers. And what that'll allow them to do is run that a little more horsepower. And of course, you guys, I know more horsepower is going to make more heat. So you need to have additional cooling. That comes in other forms than just the radiator, right? And keeping your engine cool.
Okay. So
cool too, right?
I'm sorry. So your next generation V8, you'd keep the push rods and you would add piston coolers.
Yep. So they already have them on like some of the supercharged applications, like so you think like LSA or like the LT4 engines. Those had, you know, factory supercharger, and they had these piston cooling nozzles. And what they would do is they'd obviously have in the bottom of the block these nozzles kind of pointing. Where's my finger at there? Kind of pointing up into the bottom side of the piston. So as the piston's going up and down in its stroke, this oil is squirting on the bottom side of the piston, and that helps keep it cool, keep it from melting down. So you can run more horsepower that way reliably. So it's something that I would add because if I'm making a new V8, I'm making it have more horsepower. I'm going to probably keep it direct injected for the fuel system like it is now. A lot of them have a high pressure fuel system that's directing right into the cylinder itself, right into the combustion chamber. Allows them to be a little more accurate. They can also do like multiple pulses per combustion.
Mhm.
or per event, and that allows them to be really efficient as well. I'm trying to think what else I want to add on to there. Or like, the benefit there is, right, guys that are used to like maybe a carburetor or like a throttle body injection or a intake port injection, there's just one big spray, right? And then it
Yeah.
goes into the cylinder. That direct injection, and you can just right in there, and you can do a couple little ones, and then once it's ready to really go full blast, full big bang at the end, really let it flame out hard. Yeah, it allows you to run less emission equipment too. There's a lot of benefits to that.
So they have direct injection now, right?
They do now, yeah, yeah. So I think
Okay.
they're
So
going to
you'd keep
improve
that.
on.
Okay.
Yeah, I think they're just going to improve on that a little bit more, and that would be what I would do too. Let's see what else. Here's something that's kind of out of the box. So the intake manifold is kind of a long runner intake plenum. I'm not sure if you may pull up a picture of that, but essentially you kind of see where like the cylinders overlap side to side. You just got a big hole at the beginning of the intake on these engines. And then
Mhm.
as it goes back through, the runners kind of cross over from side to side. So a long runner intake will typically give you more low end torque. And as you increase engine RPM, it'll start to kind of fall off. Whereas a short runner intake system is going to give you a little less torque, but as you increase engine speed, it's going to allow you to create more horsepower on the high end. Something that you'll see in like F1 cars and some exotics, and some like the supercars, is a variable intake manifold or variable intake plenum. So as the engine is at a low RPM, you're going to see that runner length be long. And as the engine RPM increases, that runner length starts to shorten. So you can really broaden the whole horsepower curve. So it was up to me. I would go from a fixed manifold to an adjustable manifold.
Mhm.
Yeah, getting real techie here, right?
Yeah, I'm surprised the GM hasn't had that. I know for a long time Honda engines had that before they came out with VTEC. They used to call it the poor man's VTEC.
The
But
intake runner length would actually change.
yeah, they had like some butterfly valves that would kind of open up
Oh,
that where you get more air in there or less air.
yeah, I guess I have seen something like that. But yeah, then you're kind of in between though, right? You never get that full, you're either short or you're long, where if you have that one that actually adjusts almost infinitely variable, you can have a really smooth power transition. And so something else they do now too that I try and make some improvements on or try and make a wider range for is the variable valve timing cam. And that kind of does the same thing. So I might have this backwards, but more timing advance in a cam is going to give you more top end power. That could be backwards, or more retard on the cam timing is going to give you more bottom end. Let's just say that's what it is for now. And anyways, as you allow the cam to kind of rotate, from a little bit extra and changing that timing variably, it allows you to broaden the torque curve. So torque curve, you usually kind of see it go up, it gets to a point, then it kind of starts to fall back off. Well, with
Mhm.
that variable valve timing, what happens is that comes up, you can kind of keep it in an even place for a while before the torque curve finally starts to fall. It gives you a much bigger operating window, gives you really smooth power delivery. And that's really what you're feeling with that variable valve timing. And the intake runner length thing is just going to compound on top of that. It's going to give you even more, to build on. So I think those two improvements are giving you more range there.
Okay.
I'd also go with a little bit larger cam profile too. They run so conservative. Let's put it that way on their cam profile. I would
Okay.
run a little bit more duration, and a little bit more lift.
Okay. Anything else?
Um, if if cost is no option, I'd say they should all be aluminum blocks, just to keep weight down. But it's more expensive to obviously manufacture an aluminum block, which causes vehicle prices to go up too.
They're not aluminum block now?
The 6.2s are, the 5.3s are, I believe, are not, unless
Oh,
that's changed. That's new to me,
I thought they were. I
if
don't
they
know.
are all cast aluminum, that's awesome. Keep it that way.
I don't know. I'm not sure, but okay. So you would open up the intake manifold to have a variable runner length.
Yep.
You would increase the cam profile, the duration and lift.
Yep.
You'd keep everything else the same pretty much. This is what I wanted to ask you. Would you keep the displacement on demand?
No.
No. The EPA is going to be after you, Dane.
I know. So yeah. So I would not have it, and I think a lot of people at General Motors and the engineering board don't want it either. But I believe the EPA has regulations that all auto manufacturers need to meet, where their range of vehicles need to average out to a certain fuel economy.
Yeah.
And this is a way for them to take the SUVs and trucks and bump them up just a little bit by having that cylinder deactivation.
Okay.
In real world applications, you having it on and having it off, you almost don't notice it at all, or don't notice a difference as far as at the fuel pump. It only really works efficiently in really small ranges, anyways. So it's up to me. I ditch it, but I understand why they have to have it.
So, Dane, on your Silverados,
Yep.
can you tell when it comes on?
Yeah, you can if you know what you're looking for or what you're feeling for. It's fairly smooth. If I'll give you an example. So a lot of times you wouldn't notice it on the highway because you almost have too much wind resistance for it to kick into that four-cylinder mode. But where you would notice it is like in town. So say you're cruising through town, 35 mile an hour, and you're almost no throttle input whatsoever. What you would notice is as soon as you go to accelerate a little bit, you'd have like a little hesitation, like a little chug, and then it would take off and go. And that's basically because it's kicking back into V8 mode, and it's also downshifting like 3 times because it's in like 5th gear, needs to go down to 2nd gear. And so you'd feel that transition more than anything. If you put a different exhaust on your vehicle, obviously we're not cutting catalyst off because that's illegal. But anything after that, you'd hear it, the drone. There'd be a noticeable sound that would change.
Okay. All right, cool. All right. That is Dane's idea for the next generation V8 engine.
Mm-hmm.
So here is my idea for the next generation V8 engine. All right. So I'm just kind of pretending like I'm the chief engineer of the engine of the Silverado or Sierra engine. And I have full authority. So this is what I would direct the engineers to create. Okay. There's going to be 3 things I'm going to get into. Number 1, for the displacement on demand, everybody seems to hate it. It seems to break a lot. I'm not sure if they've come up with a new part to fix it yet. I'm still hearing a lot of complaints. People are upset. So the first thing I would do is you have to have it, but I would like for them to design a way that where it could be actuated mechanically or electromechanically.
Yep.
What I would like for it to be, my vision is for it to be, you'd have something that plugs into the rocker and something maybe just above the valve. So the intake valve, part of it is kind of going up past the rocker, right?
Yep.
And then when you want to close it, something inside the rocker would lock, and then above it, it may be some type of magnet or something that holds it in place, so that you could hold the valve closed whenever you want it. And I think that's better than you trying to use hydraulics to actuate it, because over time the hydraulics, they wear out, they those lifters collapse or whatever happens. I just don't like using hydraulics to actuate this thing. I would like to use something electromechanical.
So you're thinking some sort of just mechanical disconnect.
Yeah, like how a VTEC will lock 2 rockers together and then allow it to open up further. But this is be kind of a reverse VTEC to where it would hold it close.
Yeah, kind of like a sway bar disconnect on a Jeep, right? Where you can kind of push that button, sway bar disconnects. You'd have like this mechanical link that you could trigger. Hey, I want it now. I'm going to trigger my mechanical link. Boom, it's in 4-cylinder mode or whatever. Or I want to be in V8 mode, click it and it unhooks. Then you're in full V8 mode.
Yeah. And so this way you could put this on I think you only need 4 cylinders. So you'd only have 4 of these things hooked up.
Yep.
And I don't know, just kind of as a bonus, if anyone ever wanted to in the future, just replace those those rocker arms
Yeah.
and just put something in the little connector that turns them on and just have it off all the time.
Yep.
You know, it will be fairly easy to do that.
Mm-hmm.
And if it's just an electromechanical hookup, it's not taking up a ton of space. And also, you know, if you need to replace these every 100,000 miles, then you can do that. You know, you could
Mm-hmm.
pop those valve covers off and replace those things real quick. It wouldn't be too hard.
Yeah, all you had to do was open the valve cover, which is 4 bolts on these engines. That'd be super easy to replace versus what it is now.
Yeah. So, I mean, it's a lot less complicated. And I think that people would like that better. Okay.
Mm-hmm.
Number 2. Well, I'll give you number 3 first. I would, and I know you might not like this.
All right.
My goal for the Silverado would be to keep about the same power. I think that most people are pretty much satisfied with the power of it. I would want to increase the miles per gallon as much as possible. So I would want the Silverado. This is even going beyond the engine, but I'll get back to that. I would want it to be more aerodynamic.
Yeah.
I mean, you know, any truck is basically just a brick. Is not that aerodynamic.
No,
I would just like to see if they could just get me like 1 extra miles per gallon from designing it in a way where it could still look pretty cool, but be more aerodynamic. I would be happy with that.
You know how you do that easy?
Now,
Lower it.
just lower it. Yeah.
Yeah, because there's and that's why those valences, if you notice, like on the under the front bumper, why they're so much lower than the rest of the truck, because more air over the vehicle creates less drag under the vehicle, and so just bringing them lower, closer to the ground, puts even more air over top and less drag. And that right there alone will give you an extra mile or 2 per gallon.
Do you think that people will be upset with that? Because don't they like go off road with those and stuff?
That's the trade-off, right?
Yeah. So maybe a ½ inch. Could you give me a ½ inch?
Just give me just a little bit.
A little bit.
Yeah,
and I know when they put covers underneath of them.
Yeah.
I know that helps the aerodynamics. So it had to be all covers underneath.
Oh, that'd be interesting. Yeah, if you did like full, it doesn't even need to be metal like aluminum or steel. You could do even like
could be plastic.
Yeah, like panel all the way underneath. Yeah, because both my BMWs have that, and they're super easy to pop off and on. Like there's all like little push pins. Pull them all down, the whole thing comes down and out. But yeah, there's so much less drag under the car that way. Okay. Cheap and easy way to give you less drag. But yeah, it'd be neat. I wouldn't be opposed to that. Something like that still makes it easy to service.
All right. And number 3. I know you might not like this one, Dane. But I gotta give it to you anyway.
All right.
All right. So there'll be one version of the 5.3 with my hopefully mechatronic displacement on demand. I'd leave everything else about the engine the same. But I would have a hybrid version of this truck with still the V8. Now let me explain hear me out. My goal would be is not to mess with the engine too much, except for that displacement on demand. I would want a new transmission for this engine, and I would want a transmission that is similar to the one that that Toyota uses for their hybrids. It is a eCVT. So it's a CVT, but it's no belt inside of it. It's 2 motor generators. So one motor generator is being driven by the engine. It's mostly generator, and then the other one is mostly going to be used as a motor. So there's like 7 different modes of it, and they switch between those 2 switch between generating and what's it called, receiving power. And there's a planetary gear set in there, but you know, so there are a couple different mechanical gears but there's no valve body.
Okay.
There's no torque converter.
Mm-hmm.
The main thing is 2 electric motors.
Okay.
So you'll have a hybrid battery in the truck somewhere,
Mm-hmm.
like, but it wouldn't be the huge battery that they're putting in the full EV Silverado.
Mm-hmm.
So it would be less expensive. It might be a third of the size.
Mm-hmm.
And I think and also what they do in those cars, they have an electric motor in the differential to where they can power and have the differential move just running on electric power.
Hmm.
So you would be able to use this Silverado. Hopefully, you could get maybe 20, 25 miles running on just electric.
Mm-hmm.
And then because the Toyota RAV4, I think it could go up to like 40 miles with just electric. But
Mm-hmm.
and then it'll tell the engine to come on. So
Okay.
yeah, I think that if I can get my miles per gallon up on the engine and also have that electric motor in the powertrain, and you could probably put one in the in the transfer case too, or you
Mm-hmm.
could put one in the front differential. I mean, however you want to do it, but this is what my goal would be. These ECVT transmissions are super reliable. It's so many less moving parts,
Mm-hmm.
and the electric motors, they are really good with torque too.
Oh yeah.
So that is what I would do. Those are the things I would do. Those 3 things.
That's interesting. So basically, the electric motor, you have one motor hooked to the flywheel at all times, and so that motor's always charging, or the generator's always charging on the engine, and so it's
Well, they can go back and forth. Neither
okay.
one of them is always doing anything, but they're kind of mostly doing one thing or another. But they could go back and forth. When you're decelerating,
Mm-hmm.
you could be charging. You're charging
Gotcha. So yeah,
at
it's
that
got
time.
regeneration like in the brakes and that stuff as well.
Yeah, yeah.
It'd be interesting. I have to look more into that. It sounds like a lot to go wrong, but like with any other technology, it just takes time to prove it out and make it work and reliable.
Here, let me show you this guy who
Mm-hmm.
was talking about it. Can you see him?
Oh yeah. Yep.
All
Yep.
right.
So
So
he's got one input and then or 2 inputs total. And that's like what, a viscous clutch or viscous coupler.
um, so this I think this is MG1 and this MG2.
Okay.
So these are the rotor of the electric motor, and this thing in the back over here is the stator.
Okay.
So
Oh, I see. Yeah.
can you see my mouse?
Yep. Yep.
All right, yeah. So the stator, like what it does is it turns on electrically,
Mm-hmm.
like 1, 2, 3, and it
Yeah.
pushes the motor around.
Yep. Yeah. It's
But they're
one
not even.
coil, right? Yeah. Just like any other, like a starter motor. So
Yeah,
as soon as you're putting power into it, it's going to cause the motor to turn and give you your output force.
yeah. So they're not touching, but
Mm-hmm.
they're being moved by magnetism. And you
Yep.
see here they got some gears down here for the differential and gear reduction, things like
Mm-hmm.
that. So yeah, I mean, look, this is simple. Look how this is simple.
Yeah.
This
There's
is
not much in there.
These are known for being bulletproof because you see, there's no belt between them.
Yeah. But in a
So
car, right? Will it?
yeah,
So yeah, I
um,
guess you just have to try and test and see what it can do when it goes up against heavy loads, like trucks are, required to do basically. For guys that are going to tow and haul.
yeah,
That's
yeah.
kind of
So
the downside to. That's why you don't see CVTs in trucks right now. Um, so I'll give my 2 cents quick on CVTs. I
yeah,
love the idea of a real CVT, a true constant velocity transmission,
uh-huh,
but a lot of them got just neutered and bastardized because customers didn't feel them shift, right? What you
yeah,
couldn't feel them go 1, 2, 3, 4. There is no 1, 2, 3, 4. It's just constantly going to accelerate, but it always keeps you in peak torque. So you'll have the best acceleration, you're going to have the best fuel economy. You're always going to be in the right power range, but they kind of wind out and they kind of hold that. But they're great for efficiency and power and delivery and all these things, but the customers complained. And
Yeah.
so they have these steps in them now, and they're not real CVTs, even though they still have a band in them. But anyway, I like CVTs a lot. I like the idea behind it. Your like ATVs, your side-by-sides, they all have CVT transmissions, right? They can be very reliable. But where they lack is when you have to like put heavy loads on them because they build up a ton of heat, and that's when those belts will start to fail. That's when other parts will start to fail.
Okay.
Mm-hmm.
All right. Yeah. So this is the rear differential.
Oh, dang. Yeah, so they
So
got another little motor in there too that can assist. That's pretty
yeah.
neat.
Yeah. Well, see that this one they don't even have to connect it with a drive shaft.
Mm-hmm.
Like they just turn this on whenever they want.
No kidding.
So yeah, I mean that's something that we'd have to work out in testing. Do we still need a drive shaft, or are we just going to do it with the electric motor? Because yeah, this is what I would do. I would work on the transmission and the hybrid system, and then even if you want a little bit bigger battery, you could have a plug-in hybrid where it gets you even a little bit more range. I don't think that they need the full giant battery that they're using right now for the EV Silverado.
Yeah, I've seen Nikola do something similar as well. Are you familiar with Nikola? They do like the over the road like big trucks, like semis,
Oh no,
and they're EV, but they have an onboard engine that runs a generator. So the engine's not connected to the drive line whatsoever. It runs a generator to power the batteries. And that's similar to this, right? So you don't have a drive shaft, you have independent power over axles if you wanted to, or different wheels if you wanted to, which is kind of nice about electronics, right? You don't need to run through a differential. You could do one motor per wheel and kind of do some neat things that way. But yeah, basically they just have an onboard generator that's just running all the time. And that onboard generator, with hydrogen power is what they're going for, so it's super clean. But yeah, it just keeps your batteries charged, and you get a lot of range out of it that way. You have all the benefits of electronics or electric motors, is that instant torque and delivery, which that kind of power off the line is awesome for pulling 80,000 pounds if you got that semi.
All right, well, there you have it. I gave you my idea, Dane gave you his idea. Let us know in the comments, which one do you like better? And hopefully, well, I think they've already designed this engine. Like they're just tooling up the factories now to make it. But yeah, that's how I would do it anyway.
Should we make some predictions? What's going to be new compared to what it is now?
What do you think's going to happen?
Let's see. I don't think it's going to change much. But what do I think will be new? Let me say what I think will stay the same. I think the base engine block is going to stay relatively the same, where it's got like 6-bolt mains, 2 that come up on each side and the bottom, and then there's always 2 that go in from the side of the block. I think that's going to stay the same as far as the base block goes. I'm going to say that they stay with your conventional, obviously V8. I bet you we see improvements on the new V8 for the displacement on demand. I don't see that going anywhere. But with all the complaints that they've had, I know they're already improving it on the 4-cylinder. That turbo 4-cylinder that's going like in the Colorados and the half-ton Chevy trucks. It's probably going to get whatever that update is, because they're not going to make 2 different ones. That's just wasteful unless they can come with another improvement before then. But I'm going to say that probably improves to whatever they're designed for that engine. What else? Probably additional cooling. It's probably going to, and that could be a handful of different things. Could just be oil, like an additional oil cooler, maybe air cooler, whatever. I'd say because it's probably going to make more horsepower. Yeah. Have you ever come out with an engine that didn't make more horsepower?
No.
I say we're going to see 450 horsepower be kind of the norm on the new V8. And if they come out with 2 V8s like they have now, the 5.3 and the 6.2, I'd say the 6.2 is going to be, pushing north of that 450 range, where the 5.3 is going to be pulling behind it. Right now, I think they're,
they're
420 horse now.
So maybe a new intake manifold with a better airflow, or
Yeah, maybe they
redesign the valves a little bit.
maybe they figure out how to increase the head flow a little bit, which are already really good on those things. But you could do more of a hemispherical style. Maybe they don't want to because of pride and whatever other reasons. But
All right. Well,
that
Hemi's going now, so somebody's
that's
got to do it.
true. Yeah, and everybody. I shouldn't say everybody, but a lot of people still use the Hemi design, right?
Right.
Honda and Toyota use the Hemi design and on cars and motorcycles. It's it's really good design. All the top fuel cars are still running Hemi heads or hemispherical style heads, I should say. But something like that would help. They might bump the compression a tad and require you to go to premium, which I don't think is necessarily a bad thing. Yeah, that'd be my guess. I think we're going to see horsepower north of 450, maybe even cracking closer to 500 horsepower on a OEM factory out of the box truck.
They must be doing something different because they're spending all this money to retool the factories to make it.
Mm-hmm.
So you think maybe go up to like 5.4 liters?
They could change displacement altogether, which is very possible, but I'm going to go with what history's shown. How long did they run the 350, 305, 400, like that small block platform? I mean, they ran that platform from the 50s into 99 was when the last one of those was done. So it's a really long span of time, over 40 years of that engine.
Yeah, maybe they're just changing the heads, maybe.
Yeah, so you're right. So since like the LS base is now the LT base, started in that same year in 99, 2000, and they've kind of stuck with those displacements. I'm going to guess that they kind of stick there. Would be one of my predictions. It'd be cool if they open it up. I mean, the LS7 was a 7-liter, I believe. That one was in the Corvettes. So if they open up to a 7-liter natural aspirated motor, that'd be pretty cool. But I don't see that happening.
Yeah, and I guess they would need new tooling to make if they change the cam profile.
Yeah, that's pretty simple, and it's not uncommon for GM to put different cams in the same displacement engine. I'll give you an example, like the 6.2 liter engines that were in just like your SUVs, like your Escalades or your Suburban or truck, wouldn't have the same cam profile as the LS3 that was in like the Corvette and Camaro. And those, even though the base block is relatively the same, there would be some other little differences, but that would change. The base block's similar again on those 6.2s for like the LS9 and the LSA. All those engines had different camshafts. So it's not out of their own possibility for them to have a couple different offerings where they would change that as well.
Okay. Mm-hmm. All right. Well, we are waiting with bated breath for the new V8 to come out. Yeah. We're glad they're still making a V8 at least. Dodge has got the new the I straight 6 coming out, and Ford still got their V8. So there's only 2 left, everybody. Toyota's V8 is going to, and Nissan makes their V8 still, I think, but they don't make the Titan anymore.
They don't make the Titan. You're right. They don't make Titan what else would they put a V8 in?
Well, they got a giant SUV. They put a V8 in.
Oh, that's
QX,
right. The Armada or whatever that is.
50 or 60 or the Armada.
That's true.
They still.
What do you think about? What do you think about that? The new 6-cylinder that's coming from Chrysler or Stellantis, I should say.
I like the idea of straight 6 engines. They're the most naturally balanced of engines. The Super engine was straight 6. The GTR engine was straight 6. There have been American straight 6 engines that'll be really good and reliable. I'm hoping they get all the turbo technology right, but I think they could do it. I think Chrysler has really been making a lot better product recently. So I think that it will be a good engine. Now, will people like it? I don't know. Some people complain, it doesn't sound as good, but I don't care about stuff like that.
Man, I don't know. It's not hard to make an inline 6 sound good. Like you said, there's so many examples of good inline 6 engines that are gas, not even just diesel, right? The Cummins is a 6-cylinder, and guys love that are Dodge fans or Rams. But yeah, there's lots of good gas examples. You want to go back, like one of the best engines Ford ever made is the 300 straight six. You couldn't kill that damn thing. Made all kinds of
Yeah.
torque. BMWs and Mercedes have been using a straight sixes as long as I can remember.
Yeah.
Anyways, there's tons of good examples of inline six engines out there. I like how they're bringing back the Huracan name or the Hurricane name that came from like the old Willys trucks and Jeeps from back in
Yeah.
like the 40s and the 50s. Yeah, they had the Hurricane and Super Hurricane engines.
All right.
And I forget what the displacement differences was, but they were 4-cylinder and 6-cylinder, and I think the Super Hurricane was a 6-cylinder. But yeah, so it's supposed to have it had twin turbos, right? And
Yeah,
they do a
I think
naturally
so.
aspirated one as well. Yeah,
I
so
don't think so.
yeah. Oh, just a twin turbo one, not
I think it's
naturally
just a turbo.
well, that's pretty cool. But yeah, so I'm super excited to see it. I kind of wish
All right.
GM would do something like
Wow.
that.
Well, I mean, people love their V8s, and I like V8s too. You know,
Yeah,
they got it's a different feeling driving a V8. I think
it is.
it's such a push, like from you feel that the car's pushing you so hard,
yeah,
like it's pushing you off a cliff.
once you have it, it's hard to go back. You ever hear anybody going, that V8 truck's just too much horsepower. I want to go back to a V6.
Yeah, nobody
It
said
doesn't
it.
happen, no. But I could see the argument for the inline six with the turbos.
Yeah, I mean,
That
think
makes a
it's-
lot of sense to me. Because
I think it'll be good, but we'll see how people like it. I'm sure when
Yeah.
it first come out, it'll be some issues, but I think they'll be able to work through them. And I think it'll wind up being a good engine, but we will see. We are waiting on GM. We want GM to have the best V8.
Don't do me dirty, GM. Make me proud.
All right. All right. Well, that's all we got for you today. Put in the comments whose engine do you think will be better, mine or Dane's? Or if you have your own engine that you would like to tell us about how you would design the next generation V8 engines, because V8s are going to be here for a while, no matter what anybody says.
It's good news.
All right. Well, thanks for coming, Dane.
Thanks for having me, bud.
All right. Thank you guys for tuning in, and have a good one.
Yep. See ya.